Welcome back, students. This is your second experiment in which we will learn to measure distances accurate up to second decimal place. This is your object as per the curriculum, what you have to do, in which you have to find out the volume of the material of a hollow cylinder with the help of this Vernier calipers. This is the hollow cylinder we will use. We will measure its inner diameter, outer diameter, its outer height, that is length, and its inner length up to this depth. All this we will measure with the help of this Vernier calipers. This is the picture of that, you can see. This is the picture, one of possible measurement I have taken from net. You can see it, that how measurement is made. The object, whatever the length we are going to measure, is kept here in between these two jaws, and after fitting that object into it, what we will show you through instrument also, this is the point where the observation is lying. You can see that in this point, total in we talk about in mm, it is 10 and then 1 more 11 mm or 10.1. you can say this is 11 mm here, if we are taking it in mm. So 10 mm is 1 centimeter, that's 2, you know. So this is 1 centimeter, and then one more, that is 1.1 centimeter. So 1.1 centimeter or 10 mm. This measurement we can make on small normal meter scale also. So after keeping this here, you can see that 11.1, 11.0 mm what we are writing over here. This is not exactly known to it. It is very near to, you can see this is very near to 11 point, that is 12.0. This is 11 and this is 12. So it is near to 12. When this final 0 is lying near to 12, sorry for the interruption. Actually, this is what I was saying. When this is lying near 11, near 12, still it is written 11. So the matching division must go beyond 5. You can see here the matching division is 7th division. So in this way, this distance is 11.7 mm. Another picture to clarify the things. You can see that Vernier scale about moving scale as I shown you on the instrument, and this is the main scale. Both scales are shown here to you. In this picture you can see that in centimeter distances are measured. So after 1 centimeter you can see 1.1 centimeter, same value is shown what was in that picture, and 7th division in here also matching. Same picture is there. There is not written that value, but exactly the same measurement in this picture you can see and learn how the measurement is taken. Let's work on the instrument we are using. You can see that the very first division is lying just below the 0. So there is no 0 error in this instrument. Such result is written in this form: 0 error not found. So should be written 0 multiplied by least count of the instrument and then 0. So the correct form of writing is this in red, what I have written, that is 0.00 centimeter. It is correct up to second decimal place. So whatever accuracy we have to claim that accuracy in our writing also. Now start taking observation. First we will observe the least count or minimum measurable length by this instrument. You can see that the smallest division, one division of the main scale, if we talk about main scale, so this is general centimeter scale. It is in centimeter and also in inches above, but we are using centimeter. So this is in simple centimeter scale. So smallest division is of 1 mm or 0.1 centimeter. So that is written over here 1 mm. And then number of total divisions, if you look into on this Vernier scale, these number of divisions just below side, you see this one just below. These number of divisions you can count. These number of divisions are total 10. So these divisions are counted, written 10, and least count is found by smallest value of main division divided by the total number of division. This is 0.1 mm or 0.01 centimeter. Again, how you will write this, that is already explained to you in the previous video. You will write apparatus required, it is hollow cylinder and a Vernier calipers, and sometimes we may require a magnifying glass also, so that may also be included. Object is also clear to you. Formula used is also here mentioned, and all variables are identified, so you can take it from here, and also from your lab manual you can take it. Now we will first measure external length, external diameter of this cylindrical body given to us. You can see here that the main scale reading for this instrument is 5, and then before that is 4.5, so 6, 7, 8. This is 4.8. Also you can see that it's very near to next division level, so it's about 8th division which is matching. So now see it again, what I was showing to you. Resolution of the camera and everything should be very clear, but I'm trying my best to show it to you. Vernier scale is not that much visible to you. Let us hope. Now it's focused. Yes, see it. 4.8 near to 9, and the 8th division is matching. You can see it. The same is written over in your notebook. First table number 1, for the measurement of external diameter. You can see that main scale reading is 4.8, 8th division is matching, so the net value is 4.88 in centimeter. Now we will continue taking measurements at different diameters. We will move this cylinder into it, and we will try to find those values which are different from the value we have already taken, but may not be exactly. We are always having different value because it is a very perfect and smooth surface, so we may having similarity in the values, but we will try our best to register or record those values which are different one. In this way we have recorded 5 readings. You can see these 5 readings, very minute difference. 8 is repeated 2 times, and 7 also, and 9 also we once found. So all this is on record for you. Now the internal diameter will be measured like this. This jaw will be used as I explained you in the beginning of the video. So we will measure in a similar way. We will first see the main scale reading, then the matching division, and that's what we found after measuring this. These are the 5 values. For next table, this is table number 2, and this is internal diameter of this cylinder. Now to measure the external height of this cylinder, we will take a reading and then rotate like this to have different readings, and similar readings are to be taken in the same way what we have taken for other 2 observation tables. So this is table number 3 for external height. We have measured for you, and you know how to take these measurements. We have minutely explained in the beginning. Now we'll use this instrument to measure internal height, and you will in this way we will put it. Just show it, sir, like this. Yes, just move into it like this. when it will be stopped in the bottom, then we will take these observations. So these are the observations for internal height, and you can see that these observations are also taken in the similar way, but we have explained in the first observation. Now the calculation part. For the calculation, this is the formula used, and in which all values are written in centimeter as observed, then converted into meter, and then the formula is used, substituting these values into the formula. Finally we got this value. This is 3.60 into 10 to the power minus 5 meter cube, which is the volume of the material of the cylinder, that is iron. This is iron left inside this part only, the volume of this part. This hollow part is removed, only the material volume is found, which is recorded as a result. The volume of the material of this hollow cylinder is 3.60 into 10 to the power minus 5 meter cube. Needless to say that if we know the volume, we can find the density of the material, and we simply need to know the mass of this cylinder. If we know the mass, we can find the density. So that is not the part of this experiment as per the prescribed syllabus, but in addition this may be done. Here I will explain up to the calculation of volume of the material only. So that part is over, and now you have to write down sources of error and precautions you took. There may be some errors, and what may have been the sources of those errors and precautions you took during the experiment. Standard sources of error and precautions may be found in prescribed textbook, that is lab manual. Thank you very much for being with us today.